Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances, and they've got GPU instances as well. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, ODSC, and Data Council. Upcoming events include the Software Architecture Conference, the Strata Data Conference, and PyCon US. Go to dataengineeringpodcast.com/conferences to learn more about these and other events and to take advantage of our partner discounts to save money when you register today. Your host is Tobias Macy, and today I'm interviewing Vadim Semenov about how data engineering works at DataDog. So, Vadim, can you start by introducing yourself?
Hi everyone. Thank you, Tobias, for inviting me to speak on your podcast. I've been working with Hadoop and big data for the past 7-8 years. And previously, I was working on scaling distributed systems. And with DataDog, I've been working for the past 4 years as a software engineer / data engineer. And I was responsible for lots of things that we've built there.
And do you remember how you first got involved in the area of data management?
Yeah, definitely. I remember. So the first company that I was working at, it was like ed tech company. And we were having lots of problems regarding clients and websites where we're showing ads, and we had to provide consistent proofs, figuring out different issues with who saw our ads, where we shown it, and how we compare it, and where is the fraud, and how everything mostly was figuring out fraudulent traffic. And there was a lot of logs involved, and there was a system that was built by some different team that I had to dig deep in, and it was built on Hadoop Hive. Hive was 0. I don't remember the version actually. It's 0.6 or something like that. And Hadoop was also 0. Something. It was running on EC2. I don't think we had EMR back then, but that's how I got involved. And I was really interested in the system, and I started digging Hadoop. And eventually, those responsibilities were handed over to me to overall scale the system and push it forward. So that's how I got involved into the whole big data system.
So you got thrown into the deep end and just had to figure it out as you go, as do so many of us in engineering.
Yeah, that was a pretty interesting time. There were not a lot of resources about Hadoop, and Hive was kind of first tool easy to manage for lots of engineers, because you basically write SQL and it runs. But it was all on Hadoop MR1 model, which wasn't super scalable compared to Yard. And there were lots of tricks around that.
And so one of the other things that I think is interesting is the fact that you mentioned that your title is software engineer in data. And I think it's interesting the distinctions that are drawn between software engineers and data engineers and where the sort of primary focus or primary responsibilities lie. And so I'm wondering if you can talk a bit about the ways that your role is sort of defined and the types of things that you're working on and thinking about at DataDog, and if there are any specific roles at DataDog that are more on the data engineering side and sort of where those distinctions and boundaries lie.
So that's an interesting question. So over the years, the term data engineer appeared maybe 10 years ago, something like that. And I was following it closely, and it was really software engineering heavy. People were working on lots of scaling problems and overall. But over time, the term changed its meaning, and we see it in a lot of companies. Data engineer is defined loosely now. So at Datadog, we started like moving a little bit away from it. And for every candidate and overall, we try to explain like what we mean as a data engineer. And we don't actually, sorry, we don't actually mean like what we mean by data engineer, but we explain like what kind of data engineer problems we solve. And in our case, data engineer is not someone who just implements like pipelines and writes code for analysts and data scientists. It's someone who tackles like the most challenging problems and builds like building blocks for other teams. And overall, like at Datadog, we, for example, when our data science team was working on anomaly detection, they had to build models using 30 days of data, and they started breaking our query cache, and they had to rebuild our query cache from Redis to Cassandra, which is not super typical for data scientists to work on, right? And they got obviously help from DevOps, but they wrote like some chef cookbooks that we used before, and overall deployed the system because it was their feature to deliver. And the same applies to all other engineers that we try to hire. So we try to make sure that a person is not just an expert in their domain, but can also go like to different field and figure out lots of things for themselves. And that's also shapes like how we approach data engineering. So it's not someone who just like gets requirements from other teams and builds pipelines and does stuff. No, our analysts and data scientists, they all build their own pipelines, they write tests, they manage their own clusters, and so on. So data engineering, like that's why like it's like compared like to overall the industry concept of that, we try to like explain a lot about like what we basically mean by that. So it's not going to be just like writing SQL queries. It's not going to be just like wrangling some pipelines. We have to go to some parts of our query code. We have to optimize JVM. We have to like figure out like how memory works inside of our computers and so on. We work with binary file formats. We read data from Kafka. We manage different systems. We think about ops and lots of other things.
So, in a lot of ways, it seems like you could kind of describe it as the SRE model, but applied to data problems, where you have somebody who is a quote unquote expert in a broad variety of systems that acts as sort of an enabler and a consultant to all the other teams who are focused more on the product engineering side of things to help them make sure that they have what is necessary to run what they're trying to build. And you're just trying to build out the foundational layers and the building blocks that help them do their job and help them understand how it all fits together.
Overall, yeah, like because like our company is geared toward other engineers and DevOps and SREs and other people. This approach is in the core of like everyone who we like try to like bring to Datadog. But like we have like different teams that deal with different types of data. So we have like metrics intake team that deals with high volume of data. We have analytics team that deals with like lots of variable data, and we have like revenue team that has to provide like make sure that the numbers are correctly calculated. So there's like different challenges for all those like quote unquote data engineers, if you will. And in different teams we have like different requirements, so it's not just like, but in the core we try to make sure that everybody's like kind of SRE, we, who someone who can deal with like ops monitoring, making sure that the system is fault tolerant, resilient, and so on.
And before we get too much further, can you just give a bit of a description about what Datadog is for anybody who isn't familiar with it, and some of the types of data that you're dealing with and the types of scale that you're working at?
So Datadog is a monitoring service for all kind of data, starting from ground level, like hardware monitoring, how your CPU is loaded, how much memory you use, going to upper level, like web servers or database layer, how many queries you make, how many 500 errors you throw, to completely application level, where you can see like what kind of queries are slow, why they're slow, and so on. So we try to cover a huge range of like problems that the typical engineer would face, and we help companies to know like if they have issues, where the issues appear, and so on. And the data that we deal with is pretty variable, but we can define like categories. It's metrics, basically numbers. We have application performance monitoring, where lots of like numbers and traces are tied together, and logs. which is your basically text data. And the volume of data, I'm not sure if I can disclose, but it's like in terms of like points, it's in tens of trillions per day.
So, when you're working at that type of scale and you're dealing with time series data that is being surfaced to other engineers and operators for their mission critical infrastructure, there's definitely a high requirement for reliability and uptime of your infrastructure. And so, I'm curious what types of components you're relying on for the foundational platform for managing the ingestion and analysis and surfacing of that data, and some of the types of challenges that you're dealing with, particularly because of the volume and the high uptime requirement.
Lots of people ask me this question, and they think like that we use like some kind of standard tools. But the only thing that is like standard for us is like Kafka. So most of the data we get and process gets put back in Kafka, and we have like lots of different services that consume Kafka. And Kafka, we also like we spread across different data centers, and we try to make sure that different customers get grouped together and so on. So on Kafka level, we have some resiliency, fault tolerance, because that's the backbone of like a lot of things that we do. And for different services, we have like different, like completely different clusters of Kafka. And out of that, we have like two distinct groups of consumers. The first one is real-time consumers, which mostly drive like the last like 24 hours of data, lots of alerting that we have, and they don't have to store like this data in historical plan. And inside they store in like completely custom built data stores. And in some places we use like RocksDB, but it's like an embedded database, so not a lot of things. We have some Cassandra, which is we use for query cache, as I said before. And the other group of consumers that we have is historical. So from Kafka, we also consume data, and then we write it to in custom file formats to cloud storages, and then the query system can easily get data either from live system or historical system. That's how we show data overall.
I find it interesting that you're working in a custom file format, particularly for some of the historical data, where I'm sure that there are a lot of benefits that you gain as a virtue of having them built for your specific use case. But at the same time, it adds a bit of extra burden for onboarding engineers because they have to learn a specific tool rather than being able to translate information or experiences that they've had from other companies. And so I'm curious what your experience has been on those lines as far as any friction that is caused by having more custom tooling where you may have been able to take advantage of something off the shelf for a slightly less optimal performance or capabilities.
Yeah, so the goal of those like custom file formats is to allow customers to see data as soon as possible. So whenever on a dashboard you open and want to see like, for example, 7 days of data or like 1 month of data, that's a lot of data points. And we have to show them as fast as possible. And we try to make sure that like within a minute you can get data. So those file formats are really optimized for reading data. And for engineers, as long as you have like tools, so for example, it doesn't from outside perspective, it shouldn't matter like if it's like Parquet or like some other file format, as long as you get data like with a certain schema, right? You don't really care like as long as like that schema is the same. And we have lots of tools for that. And overall, there are like some challenges because of the system is so big. There's like lots of like moving parts, and it's not just like a single file. There's like lookup tables, index files, etc., etc. But we decided that that's the way to go. Unfortunately, we have some for some intermediate data. We also use Parquet, so we're not only just using our custom file format. So, for example, for analytics purposes and for other more flexible use cases, we figured it out that we actually want to store in Parquet, and we do store in Parquet. However, we apply some higher order aggregations there, so we don't store all the volume of data in Parquet. And in terms of data retention, we store everything with 1 second resolution for over 15 months. And customers can request, obviously, like longer periods. But essentially, like our system is optimized. Like if you want to see like what was happening in your system last Black Friday, for example, to forecast like what's going to happen this Black Friday, you can easily go on dashboards and check what was happening down to a second in your system. And that's what like historical data is useful for.
Yeah, being able to maintain that 1 second tick resolution for such a long time frame, I'm sure, has some storage challenges. I'm wondering what the compressibility of the information is, given that it's all working along discrete time intervals, and there might be some similarities in the patterns for being able to compact the actual files on disk.
Yeah, so we're not doing like extra like research, extra rigorous research about like how we can compress all the data, because like as you said, like the data is so variable, and there are like different techniques, right? If you were looking at like Parquet, like they have like four different techniques of encoding like data, but we don't do that, and we achieve about like 15x compression ratio. So whenever you see you look at raw data, it's probably actually even more, because I was comparing compressed data from Kafka, and then we group data and compress the actual time series. So in reality, it can be like close to like I don't know, like 25, 30.
And then another interesting piece is because of the fact that you're using these Kafka clusters running across multiple different data centers for ingesting customer data. I'm curious how you handle routing of that inbound traffic to reduce latencies and ensure that you're getting sort of the optimal performance and time to alerting for people who are sending you metrics, and understanding sort of what the locality is of the origin for being able to determine what those optimal routes are.
Yeah, so we usually like we don't allow like customers go across like clusters. So if your customers, you're probably gonna live in like a certain cluster unless you like have special agreements with us, and that's why that's how we avoid lots of like intro traffic, right? Because like clusters kind of independent, and within our systems, we can quickly switch different parts of our systems between clusters, and we try to not maintain state as much. So for example, for historical data, we only like keep last 10 minutes, and whenever we switch to a new cluster, we just need to replay like last 10 minutes of data. So we don't need our Kafka clusters to talk between each other. But within a region, we obviously deploy Kafka clusters in multiple availability zones, and that's where we get lots of traffic. Unfortunately, I don't really know all the details because it's like falls not outside of my work. We have like completely separate teams that work on Kafka. They're called like data reliability engineers.
Yeah, so that's a good opportunity to talk a bit more about what the team structure looks at for the people who are working closely with the data at Datadog, and what your particular responsibilities are and how you work within the organization, particularly given the fact that Datadog has grown in size pretty significantly over the past few years. And so just sort of how you coordinate the projects that you're working on across the team boundaries and across geographical boundaries.
Yeah, so first of all, like when I joined like 4 years ago, Datadog, we were 150 people company, and over 4 years we've grown to 1,300 people. So we 8x growth, I guess, and it put like lots of like pressure on like how we'd structure teams and how we do work overall. At first, like we had like pretty flat organization, and now it's we add layers, and we had like people who like gather requirements, like product managers, directors from team leads, and we compose like objective key results for every quarter, and we have sprints, obviously. But besides that, we do a lot of documents. We start doing lots of documents. So whenever like we're working on some big project, actually like no matter what kind of project, like it's all like case by case, but we created like a document where we request comments, and lots of different teams can come and comment, and we request from different teams what do they think, how it should look like, how it's going to work with other systems and other teams. Obviously, it's not super perfect. There are still problems, There's still some challenges, but we're working on them. And like as any probably as any growing company, we experiencing the same issues, and we're trying to overcome those. I hope I answered your question.
Yeah, no, that's definitely good information. It's always interesting seeing what the team dynamics happen to be and what the breakdown is of responsibilities across different organizations because in broad strokes, we're all working with data, we're all doing what looks to be the same thing at a high level, but as you get closer in, there are a lot of different ways that people break down the responsibilities and what the main areas of focus are. And it's interesting how the specifics of the business influence or dictate what those boundaries happen to be.
It's usually like when we start like a new project, and like it is all within a team. Like a couple of people are working on it, and over time it grows to like a bigger project, and then like out of this a new team gets born. Yeah, but that's usually the dynamics how we break things. Usually like some small project that has grown to a certain size, and people break into new teams. The funny part about that is like how we handle ops. That's because like you have like a big system, and you have people in like lots of people being like kind of rotation to support the system. And once you break it apart, like different teams, like who's responsible for what, that kind of becomes a little bit interesting to figure out.
And then, in terms of the work that you're doing, who are the main consumers of what you're building, and how do you work in feedback cycles to ensure that their needs are being met and that you're meeting the feature requirements for the types of systems and primitives that they require to be able to get their job done?
So I work in kind of between. I deal with receiving data directly from Kafka and storing it in custom binary file formats, and then also providing it in different formats to other teams. So for me, we have both like customer-facing features and internal SLAs that we have to support between, like for example, revenues team and analytics. So up until like I would say like maybe like half a year ago, lots of requirements were coming from how like we operate the Poly product and pipelines that we've built, and how well it can scale. Lots of things that we've built early on were not built in mind with like such a high growth in mind, and they were started breaking apart. And that's what mostly we were working on for the past like 3 years, in like at least like in my teams. And now we are going into territory where like we fixed most of the like scaling issues, and we don't really have them. And we were building systems with like 10x growth, which should be enough for another 3 years. And now we can concentrate on other things, other requirements that now come from different parts of the product. So, for example, we recently released histograms for which our data scientists developed a new sketch algorithm, and we're trying to make it available for historical data as well. We also released SLIs for our metrics, and we also trying to make it work for historical data as well. So now it's more in realm of bringing features that we have in like live systems to historical data, and lots of people need it. And we also have lots of development in the data science front, where we want to apply machine learning not just to live data but historical data on larger periods of time.
And I know that machine learning is often something that's challenging to be able to run in a production context because of the fact that there can be model drift and there's not really a easy way to do deterministic testing of the model to make sure that it's operating optimally. And so I'm curious what types of challenges that you're dealing with or platforms that you're leveraging to be able to handle those machine learning models in a production environment for being able to do those historical analyses.
So I'm not really aware about all the things in the machine learning offering that we have, so I might be wrong about some parts. I'm sorry, but overall, the main challenge there is how you create a general approach for all kind of different time series data that customers have. How you generalize that And there's only so many things you can do. You can try build, and also like how you can make sure that it like runs fast, it doesn't have lots of false positives, and so on. And we released like first like anomaly and outlier detection algorithms like 3 years ago, and we saw some adoption. But personally, for me, I tried it. It's difficult to interpret models, like when it shows you that you have like an outlier and anomaly here, you're like, why is that? Like, how, like, why model decided that it's like a problem? So I personally like not sure about how I feel, and I'm actually not sure how like overall this problem can be solved. We have like other offerings, for example, Watchdog, where we try to find related stories. So for example, whenever like you have spike in your database connections, we can relate it to some certain like other time series and show you that maybe those are related, and that's where you should look at. We also have some other machine learning capabilities, such as figuring out patterns in logs, which is really helpful when you have like a constant stream of logs and you want to figure out what's happening often and what happens rarely. But in general, like those like applying machine learning on such a big scale, it's really difficult. And companies who have their own like things that they have like internal monitoring solutions, they can really flex there, and because they can like build like certain models that really tied close to like their problems.
Yeah, it's definitely interesting in your particular case of building these models that are feeding into some of the decisions that other operators are making based on the anomalies that can get surfaced, and being able to explain in a quick and accessible manner where those decisions are coming from and what types of actions might be useful or what types of insights you're trying to convey to them so that they can be able to make the necessary actions or determine whether an action is even necessary at all.
Yeah, definitely true. Overall, like that's like overall the goal of the industry, and like one of the things where I joined Datadog is to I wanted to help. Like we have like so much data, and ability being able to correlate it and figure out problems early on would be really nice to have, but it requires like tons of computer resources. Fortunately, or fortunately, I don't know.
And then the other interesting thing about the problem space you're in is that you're reliant on the end user delivering data to you, and it's time series, which there are always issues about the order of deliverability, where you might be having somebody who's sending data out of order, or they might have agents that are having networking issues that will maybe bunch up a bunch of data and then deliver it all at once, but deliver it late. And then there's also the fact that because you have end users sending the information, they're, as long as they're using your agents, it's likely that the schema is going to be accurate, but they might decide to start sending extraneous information or misformatted data that doesn't match the schema that you're anticipating. And so I'm curious how you deal with all of those issues of data cleanliness and some of the challenges that are specific to time series.
Cool. Yeah. So the first front is figuring out if data is malformed or not, and we quickly filter it out if it's malformed on our end. And about late and future arriving data, we have pretty loose windows. So everywhere we say that we accept up to 15 minutes in future. Like so, if your point came with a timestamp that is in the future, we'll accept as long as it's not farther than 15 minutes. And for later arriving points, yes, as you said, like sometimes like servers or hosts like are slow, there's like some bottleneck problems, or you can send like custom completely time series. We accept up to 3 hours in the past. So we have to wait until we can actually start processing.
Yeah, and I know that that can be challenging for the application logic that you're dealing with, because you're trying to maybe build some windowing or build some insights into the stream of data as it's coming in, and then all of a sudden you get a whole nother batch of data points from 2 hours ago that you then need to recompute some correlations between two different systems or two different metrics that are coming in. And so I'm wondering if you have had to deal with that in your own work as far as being able to realign the data.
Yeah, so because like we wait like 3 hours in the past and 1 hour in the future, we store data in 4 hour chunks, and basically we have to use like 8 hour windows, and 8 hour windows kind of overlap. And then we have like other problem. We also have like orgs that can migrate into different shards, chunks, etc., etc. And tying all this data together is a big problem, and we've been working hard on it to figure out like how to do correctly migrations. So, for example, if a customer grows too big for a certain shard, and we move it to a new shard, how it's going to work with overlapping data, how it's like late arriving data is going to go, and so on. I wouldn't say that like we solve all the problems. That's a lot of thinking went into it. And the problem is, as you said, yeah, lots of systems also use the same data set, and they also have to have all those capabilities. We defined some strict rules about doing such migrations, and we try to follow. And overall, like we still in trying to solve all those problems with like overlapping data time windows.
And you've been there for a few years now. I'm curious what you are most proud of, or what have been some of the most interesting projects that you have been engaged with. And out of those, any of the lessons that you have found to be particularly valuable or unexpected or just interesting issues that you've had to confront.
Oh yeah, I have stories. So initially, when I was hired like to bring Spark support to Datadog. Overall, we used to use Pig as our processing framework, and bringing Spark support was pretty challenging in terms of I had to. We have internal platform that we use to launch jobs, like kind of like Qball Databricks, and I had to like write like lots of code there, like figure out like optimal settings for all the Spark clusters, then write a bunch of tutorials, figure out how we're going to compile code, how code is going to be delivered, how it's going to signal our workflow management framework that work is done, and so on and so on. There were lots of challenging aspects about that. And then once it was built, like we started like moving like some historical processing toward it. And then the challenge was like how we use Spark. Back then it was Spark 1.6, Spark 2.0 was still in development, and we were pretty hesitant to use it. And Spark 1.6, we thought like, yeah, it's great, it's reliable, it's stable, but turns out it's not. Like there were like lots of places where it crashed. And over the past like 4 years, we've grown some expertise around Spark, but it still throws like some interesting problems on our plate. And then like while we were working on like different like systems, we had to dig deep into like how JVM works, how memory is outlined, how does word aligning works, how much space our data structures take, how garbage collection works, how to put everything in off heap, and so on and so on. And we actually found like some bug in Scala itself and Spark. And we didn't help to fix it. We just noted that yeah, actually arrays can be bigger than this number, and so on. So there are lots of things that I learned is that, for example, for Spark, it turns out like not like at the scale that we use, not a lot of companies use it actually, and lots of like problems we've ran into, nobody've seen before, and we had to like figure out like, oh, how are we gonna do this and that. And on top of that as well, we run most of our jobs on spot instances, which means that your cloud provider can take them away at any time. And this creates like such a violent environment. And when you have like clusters of like 5,000 cores and your instances are constantly dying and Spark runs on it, you realize that you're probably not everyone's doing that, what we're doing. And whenever you have a problem, you're like, okay, I'm on my own. I need to get all the stack traces, all the logs, and figure out like what's up. That's just a small portion of problems we've ran into.
And the last 4 years have also been an interesting time in terms of just the overall shift in direction for both data platforms and operations and infrastructure platforms, particularly with the rise of Kubernetes and just overall container-based systems and the proliferation of cloud platforms and cloud environments and different services. And so I know that Datadog also supports a number of different direct integrations with things such as Amazon or other cloud providers or third-party SaaS platforms. And so I'm curious what that overall shift in the technology landscape has meant for you and your work at Datadog and the types of requirements of the systems that you're trying to build.
Yeah, definitely. So overall, like as you said, like the cloud is still growing, and then there's like second wave, like where everyone is moving to containers, and Kubernetes and everything. And from my perspective, for example, one of the biggest problems that we had to face is that containers live so short period of time, and for each like you're gonna have so many container IDs, and some of our systems were not built in place for like churn of like tags basically, and we had to fight that, and it created like different challenging problems. The other part is like we made a huge push to move in all the services in Kubernetes, and as part of my job, I had to move lots of services to Kubernetes as well. And that's not always part of like what data engineers do, but that's like, yeah, that was my problem. We had to do it at Datadog. So I got a hands-on with like Kubernetes. Overall, like we use Kubernetes extensively at Datadog, and for some more services, there are like some challenges, but also it's still for me it's difficult to judge like how easy it is to use for like ordinary engineer, a typical engineer. But like the benefits of Kubernetes, I can see that, and I can see the platform prevailing. And so far, like we've been releasing lots of reports about cloud adoption, container systems adoption, and we've been showing that Kubernetes is growing and Docker is growing as well. So that's just like the life we have to live with.
And as you look forward to some of the projects that you've got planned for some of the coming months and years, I'm curious, what are some of the types of technologies or best practices or overall patterns and systems designs that you're trying to keep an eye on or that you're hoping to adopt, and just some of the overall types of challenges that you're anticipating as you move forward?
Yeah, so at Datadog, we're not really hyped about different technologies. We we've done some of them. We saw lots some problems, and as like at our scale, picking up a technology is a pretty. We should be conscious about how we approach that. So we don't really like put lots of like thought, like lots of like figuring out what kind of technologies we're going to use. Instead, we put a lot of efforts in like how we approach engineering, and built-in fault tolerant resilient systems is where we want to be. And overall like the problems that we're going to face next, from my perspective, are going to be related to that. And in terms of the actual one, it's probably ops. So the number of services keeps growing, but the number of engineers is not growing as fast. And overall, like a human can only have like keep so many things in their head, and you want to make sure that ops is like automated. So we need to make sure that we are building a system that can auto recover, can have retries, can have proper login, monitoring, etc., etc. We can replay data easily, and so on. And the other part, which is going to be huge for us, I think, is migrations. So at our scale, like when we develop new systems, we can't just roll them easily. We have to run them for like a certain period of time, like half a year, for example. And when you run huge systems on such scale, they burn lots of money. So you have to figure out like instruments that will allow you to move some data between those two. And then on the other end, you have systems that consume this data. And you have to make sure that those systems work reliably with partially migrated systems. And that problem we haven't seen like being solved. Like there's like not a lot of like guidance, and we have to like develop our new techniques about that.
Are there any other aspects of your work at Datadog or the types of projects that you're building or the platform in general that we didn't discuss yet that you'd like to cover before we close out the show?
We have like some internal projects about like Spark performance monitoring. So I feel like lots of companies, lots of people run like their jobs, like lots of pipelines, but nobody tracks like how performance of those jobs like degrade or improve over time, or with certain like code pushes, etc., etc. And we're trying to, in our case, like we have like hundreds of jobs that we run, and we're trying to see like how certain changes improve or break like jobs. Um, and we're working on it, but I'm not sure like how and when we're gonna release it. And we've researched like other open source projects, and we haven't yet seen like this. And I had like some conversations with other engineers with other companies, and like I feel like that's like one of the problems that data engineers have. overall, and like businesses is like how can you measure how efficient your jobs are?
Yeah, that's definitely a challenge because of the fact that there is such variability and seasonality of the data that you're dealing with. So the execution time of a job at one point in time isn't necessarily indicative of its overall performance because it's highly dependent on the data that it's working with. So unless you have very consistent data sets that you're processing on a regular basis, it's definitely difficult to be able to say with any high degree of certainty whether a particular tuning is having the desired impact without being able to measure it over an extended period.
Yeah, definitely. So we not just collecting like Spark metrics or YAR metrics or like system metrics. We also collect data from the jobs itself, and you have the same code, but you can run like as you said, like on different like data inputs, different like time periods with different parameters, and the same code will be executed like different variations on the same hardware, and we're trying to like figure out how all those parameters relate to each other and whether we actually need to improve our jobs or we are fine, because essentially like the basic question that we want to answer like a couple, like is our uh, will our jobs work for the next like 3 years, how much money they will burn, and when we should start looking closely at that, because cost optimization is also a really huge part of like what we do.
Yeah, it's definitely an interesting problem space. For anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
That's a really good question, Tobias. See, like I'm not super like in data management. The space of the data that I work with is pretty limited. The volume is big, but from what I've seen is like workflow management is still like kind of not solved. We have like Airflow, which still has some certain problems. We have like different other workflow managers, and overall like rescheduling pipelines, rerunning, reprocessing data, waiting, alerting is like I am yet to see like a product that solve like workflow management to like complete degree.
Yeah, I agree that the workflow management space still has room to grow. And it's interesting to see some of the generational approaches to it where, maybe 15, 20 years ago, we had things like SSIS and a lot of the GUI driven tools such as the Jaspersoft suite or what came out with things like Pentaho. And then there was the sort of second generation, which were things like Luigi or Airflow, where we were moving more towards the workflow defined as code and being able to have it in a more software native approach. And then a lot of that was a bit too rigid in terms of the way that it was defined and executed. And so now we're starting to hit the third generation where we have tools such as Dagster and Prefect and Kinto that are trying to blend the requirements of data engineers and data scientists. And there still seem to be some rough edges or incomplete execution of some of the overall requirements for this space. And then you've got things like Apache NiFi that are trying to revisit the GUI oriented type of thing, but work in more of a data flows type paradigm. So it's interesting to see a lot of the different generational and paradigmatic shifts in terms of how people are trying to deal with this as we deal with more data in terms of volume and variety and the different environments that we're dealing with it in and the types of consumers that are trying to be able to gain value from it.
Yeah, absolutely. I totally agree with you. And the other one that I was thinking about is that I get like I go to different conferences, I present at conferences about like things we've built with Spark, and lots of people like approach me and start asking questions about like why my job is so slow. And if you go over like Spark like user release, you also like get like these kind of questions. And this like MapReduce model that we that's been around like for 15 years or like I don't know 20. We still use it, and the people there's not lack of understanding like why is that like, and still people still like puzzle about like why jobs are slow, and there's like no solution so far. Like even Databricks haven't like they don't have like magic wand that's going to show you, oh, this is why your job is slow. So there's like still room for like building expertise in that field, I think.
Well, thank you very much for taking the time today to join me and share your experiences of working at DataDog and the types of challenges that you're facing there. It's definitely an interesting platform that you've built and one that I use for managing my system. So I appreciate all the work that you've done, and I hope you enjoy the rest of your day.
Okay, thank you, Tobias. Thanks for having me, and I wish you all the best, and everyone have a nice day.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.